All right, so we've talked about phylogeny. No, we haven't talked about phylogeny. We've talked about speciation. Talked about what is a species. We had lots of arguments about it. People didn't agree. Most of you guys seem to agree that biological species, but it's not because it's the best. It's just because it's the least worst. We're going to take all of that knowledge we just did and put it together for what's known as systematics, taxonomy, and phylogenies. That is, how are we going to actually apply that knowledge? Taxonomy is the science of naming and classifying extant organisms. That means those that are currently in existence. And typically we're going to follow a hierarchy about it. We've talked about Linnaeus, who came up with this nested hierarchy. That's what we still use. We start off with the most general and get more and more and more specific. The hierarchy goes at the top, the domain, which is kind of still new for me. I mean, it's been around forever. Probably you guys learned about the domains when you were in elementary school, but that didn't exist when I was there. The supergroups under the domains, the kingdoms, phylum, class, order, family, genus, species. I will not make you memorize that, because that's a waste of brain space. But you start off with the higher levels, the kingdom, where you might have, animalia, bison and monkeys and people and turtles and birds and echinoderms, starfish, lobsters. And then you get more specific, the phylum, chordata, those with a backbone. Well, now we wipe out, we don't talk about the starfish and the lobsters anymore. Now we're specific to the bison, the monkeys, the people, birds, and turtles. Class, mammalia. We're even more specific. We got rid of the turtles. Order, primates. All right, we get rid of the bison, the birds. Family, Hominidae. We get rid of the lower the lower monkeys, the lower what are those things called? Primates. And then we end up in genus Homo, where we've gotten rid of the chimp, and we've got Homo erectus and Homo habilis. There's a few Homo lines. And now we're very, very, very specific at Homo sapien. From the very general down to the very specific. Taxonomists try to put groups into what are known as taxons. Taxons are simply groups of organisms that are really closely related to each other. The taxons are the domains, the kingdom, phylum, class, order, family, genus, and species. All organisms can be divided up into 3 domains: bacteria, eukaryota, archaea. Those 3 are distinctly different from each other. They branched off of a universal common ancestor. Because remember, eukaryotes, what do they have? They have membrane-bound organelles. They have compartmentalization. Typically, you think of them as having a nucleus. Bacteria lack those things. There's some other issues. Archaeans also lack those. These are both prokaryotic. A big difference between them we're going to get to when we talk about prokaryotes. We're going to talk all about the chemistry of their phospholipid bilayer versus ester versus ether linkages. Here's domain bacteria. They are, not surprisingly enough, bacteria. You have some that are blue-green. You know what those are called? Blue-green bacteria. Cyanobacteria, or cyan. You might have your archaeans, your extremophiles that live in very, very extreme conditions like boiling hot water, beyond boiling hot water, acidic environments, basic environments, super salt environments. What? Absolutely frozen environments, frozen deserts, things like that. I mean, there's a lot of differences between bacteria and archaeans. We're going to get into these differences when we talk about this in very, very shortly, when we talk about prokaryotic organisms. Then you have domain eukarya. All the rest, anything that you can see with your eyes, not through a microscope, is going to be a eukaryote. Even some of the smaller ones that you see with just a microscope that have a nucleus are eukaryotic. Beneath the Domain level, you have your supergroup level. Excavata, the land plants, Alveolata, Stramenopilla, Rhizaria, Amoebozoa, Apustacanta. Then you have the kingdoms, the land plants, so Plantae, Animalia, fungi. All of these are going to be separated, they're all going to be organized, and they're all going to be named. And we use what's known as binomial nomenclature for naming these organisms. On your exam, I'll tell you, you're going to have to name an organism. I'm going to let you name it. You get to name it whatever you want to name it as long as it follows these rules. It will have a genus and a species, a general name and a specific name. This, for instance, is a horseshoe crab. Everyone calls it a horseshoe crab. They live along the Atlantic coast. Its binomial nomenclature is Limulus polyphemus. Limulus is the genus name, Polyphemus the specific. Genus names are always treated as nouns, even if they seem like they're verbs. Fast dog, for instance, in Latin. Usually these names all are in Latin or Greek. They were the scholarly languages. And each name usually describes the organism. So for instance, Oloropoda melanaluca is the giant panda, but it doesn't mean giant panda. It means black and white catfoot. Because that's what it's describing. So when you hear these scientific words, they're describing the organism. Ursus maritimus. We call it the polar bear, but what it means is the maritime bear or the ocean bear. Why? Because it swims. Canis rujus, the red wolf. Why? Because it's a red dog. Canis means dog, rujus means red. Sometimes you don't get descriptions. Linnea borealis is the twin flower, which means the northern Linnaeus. Named after somebody. We do that a lot. We name things after people. And sometimes the common name, you don't use a common name because nobody talks about it commonly. Fucinus brasiliensis means Brazilian sea snail because it's the Brazilian sea snail. That make sense? But people do break these rules, and it can get fun. For instance, we have colon rectum was an insect that they discovered. Aggravation. Why? Because it took them so long to categorize it that they got mad and they named it literally aggra space vation. The ahaha. Like Capilloni, which is the genus, and then Harrison Fordiae, because they were trying to get Harrison Ford's attention. This is one of my favorite. This is excellent science right here. Agathidium bushii, Agathidium cheney, Agathidium rumsfeldii. These were all members of the George W. Bush administration. Right, Bush, Cheney, and Rumsfeld, right? And so they went. The scientists got invited to the White House because they named them after these guys. But here's the deal. Well, it gets funny because you don't know what the scientists' political affiliation are because these are all slime molds. So, yeah, are they going to name it in honor of the guys, or are they just making fun of them, and nobody can tell? That's good science. Carmen Electra, who was I'm not sure if you know, she was a 1980s, 1990s model. She kisses me. Yeah. The Oedipus complex. And let me tell you about piece of cake. They named it piece of cake. It is genus Pisa, but apparently they were driving through a tropical rainforest, not a rain, but the road along a tropical rainforest, and the bug hit their windshield. And they're like, we've never seen a bug like that before. They got out, and it turns out it was a new species that they got to name, piece of cake.